Okay, this video is dedicated to the introduction to writing equations for linear lines. Okay, so we've already done practice of graphing linear functions where we notice we get a straight line, we have a starting point and some sort of direction or slope. Now we're going to go backwards. We'll say given a line or given information, can we write an equation that shows that relationship? Now the key to this video is we have three different forms to write equations in. So you can have one line and write it three different ways. And they all have the same relationship, but we just put it in different forms depending on situations. For instance, if you have a person named William, you can call him William, you can call him Will, and his buddies call him Bill. So you have like three different names, but all referring to the same person. So that's what we have going on here. So let's take a look at the examples. The first one is slope-intercept form. So this is where we have both the slope, okay, and the y-intercept. So I'm going to highlight those things here. When you are given the slope and the y-intercept, then you can use this. The key to all these equations is you need some sort of starting point and direction. So I'm going to put a note up here to talk about that. So we have starting point, and then we have direction. So those are the two main things for writing a question. If you have those two things, then you can go ahead and start filling in one of these forms. So that's the B factor here, okay? Now the other one is point slope form, okay? So let's say you don't have the y-intercept, but you just have an ordered pair of x comma y, any point on the line, and you still have the slope, okay? So again, it goes with a starting point that's perhaps not on the y-intercept, but anywhere in the graph, and then slope from there. Then the last form is called standard form. We really don't use this a whole heck of a lot for graphing purposes, but it's a great way to organize information. So what makes standard form standard form? Okay, notice A, B, and C are numbers. Okay, so C is the numbers all by themselves. So the numbers go on the right hand side equation. Then on the left hand side, we always do X first, okay, and then we do Y next. So that's second, okay. And the key is we want integers or whole numbers, okay, meaning no fractions. So it's a great way to organize. We have like x's first, then y's, then numbers. So that we have multiple equations, we can organize it nice and easily. It's nice and clean to see, no fractions, nice and simple, okay? But again, it's not very conducive to graphing. So a lot of times we take this form, change it to the other forms, and go from there. All right, so let's take a look at some examples. So what we want to do is, in this here is, can we go from one form to the other? We're not changing the line, we're not changing information, we're just changing form. It's like, you know, my friends call me Bill, but my parents call me Will, okay? But you're the same person. So let's take a look here. So we want to convert to slope-intercept form. So when I do all these, I'm first going to remind myself, what is slope-intercept form? What it is y equals mx plus b. So the key is to this is to get y by itself. So that's the key. So maybe I'm going to go back real quick and add that to my notes. So the key is for this to y by itself. That's a good note for slope-intercept form. Okay. All right, so let's go back to the example. So to do that, I basically have to move the 2 to the other side. Now before to do that, I get rid of those parentheses. So I'm going to first distribute the 3. So 3 times 4, then is 12. Okay. Now to get y by itself, I'm going to have to move the 2 to the other side. And we have y is equal to 3x plus 14, okay? Now from here, I can highlight the information. What's the slope? Okay, the slope is 3 over 1, okay? And then the starting point is 0, comma 14. So the nice thing about changing the form is now we can get certain information from that equation, okay? Now this is in point slope form, okay? And let's talk a little bit about point slopes. I'm going to go back to this example here. Point slope form is you have an x and y. So this is like x1, y1. So those are shown right here. Okay, so we have x1 and y1. So what we do is we do y minus the y value and x minus the x value. These x and y's and that come first don't change. And you have the slope right here. So it has a starting point and a direction. So those are the key things there. In this equation, notice we need the slope and the starting point on the y-axis, okay? And then over here, the key things that we need is the a, B, and C. And we get those basically from one of these two equations. So when I look at this, we usually start in this form and go to here, or we start and then we go to here. A lot of times we start in this form. So let's take a look here. So notice we get an example. So here, what's the point? Okay. You take the opposite value of those things. So where this came from was -1 comma 8. Notice this change in sign. Okay. Change sign. Okay. And anytime it's in parentheses like that, you switch the sign. Okay. And then the slope is 1/2. Okay. Now the key is we want to put it in standard form. So standard form again is ax plus by equals c. X and y on the left, numbers on the right. All right, so let's go ahead and take a look here. I'm just going to move this out of my way. And let's go through this. Now, the first thing I want to do is get rid of parentheses. So I want to distribute. Nothing to distribute there, so that's fine. And then 1/2 times x is 1/2 x. And then 1/2 times -8 is -4. Okay. Now again, I want to get the x and y on the same side and numbers on the other. So I'm going to move the 1 to the other side of the equation. Okay, because I want numbers over here and then x and y on this side. So now we have y is equal to 1/2 x minus 5. Okay, I'm going to move the x to the other side because I need it on the left. So I'll subtract 1/2 x. So we have -1/2 x. I'm going to put x's first and then y's, alphabetical order in this case. And then 5. So notice it's in standard form, x and y and the numbers on itself. But the key is we cannot have fractions. We have to have some sort of integer or whole number. So I'm going to get rid of this fraction. So this is called clearing fractions. I'm going to multiply everything by 2, both sides. And when we do that, the 2 times the 2 cancel, and we're going to get -x, okay, plus 2y, distribute the 2. And then over here, what's 2 times -5? -10. Okay. So that's what we're going to have in this case here. Okay. All right, so let's go ahead and put in slope-intercept form. So I'm going to put a reminder. Y is equal to mx plus b. Okay. So that's slope-intercept form, slope, and then intercept. So the key is get y by itself. Get y equals. So I'm going to move the 3 to the other side. So first, I need to distribute. So I distribute the 7. Next, move the 3 to the other side. Notice I combine like terms. Y is the only thing left over here, so I know I'm done on that side. Then we have 7x. There's your slope, and there's your starting point. So from here, I could say slope is 7/1, and the starting point is 0, 17. Okay. Let's go ahead and take a look at these two examples down here. Extend my page just a bit. Okay. And rewrite the equation in standard form. Okay, so notice it is in y equals mx plus b form, slope-intercept. Standard form, I'm going to get the x and y to the other side. Now, before I see the fraction, I don't like to work in fractions, so I'm going to multiply by 3 right away and get the fractions out of there. And I know multiply 3 because that's the denominator. So on this side, we have 3y equals 3 times 2/3. Notice the 3's cancel, and you're left with 2x. And then 3 times 5 is 15. So notice, no fractions. Now, numbers are on the right, letters on the left. So we need to move the 2x to that side. So I'm going to subtract 2x from both sides. I'm going to put the x's first. I cannot combine those because one's an x and one's a y. And there we go. I know I'm done because I have ax plus by equals c. X and y on the left, numbers on the right. So this is a great example there. Okay. Let's do the same thing over here. Okay. Now notice, what's the slope in this case? The slope is always in front of the x value here. So the slope is 1. So notice we don't really need to distribute, and there's nothing to distribute over here. So I'm just going to write it without the parentheses because there's nothing outside the parentheses. It's good to pick up on that. I'm going to get rid of the fraction. So I'm going to multiply by 3. So notice 3y, 3's cancel, so we have 5. 3 times x is 3x. 3 times 6 is -18. Okay. Again, I get numbers over here and then xy over here. So I need to move the 5 to the other side. And then I like to do one step at a time. So I'm going to show that there, and then 3x minus, and then what's that, 23. Last step, move the 3x back to the left-hand side, and we're left with, I'm going to put the x's first, then the y's, and then the number. Okay, so there's a great example of what it looks like. Okay, so notice in this thing we're to talk about switching forms one way or the other. Okay, all right, now this is the last example I'm going to show in this video, and what we have is this is slope, point slope form. Okay, and notice we have the point. I'm going to highlight again, x1, y1. So I'm looking for a starting point. It has to be this. And we know the slope right here is 5 over 1. Okay, so you have to identify the pieces. So let's say I had a graph. We know the slope, but we need to start somewhere. So I'm just going to sketch a graph. We want to start at 1 comma negative 7. So I'm going to go over 1, down 7. So there's the point, 1 comma negative 7. Okay, I'm just sketching this out. Now from here, we have a slope of 5. So I'm going to go up 5 over 1, up 5 over 1, up 5 over 1, and so forth. And then we can have our line. So notice I don't have to start on the y-axis. I can start anywhere on the graph as long as I have a starting point. So that's what we're trying to establish in this example. We're saying if we have the equation and a starting point, let's plug the starting point in. So I'm going to put y minus equals 5 and then x minus. So this is like the skeleton equation. And then I'm going to plug in 1 comma negative 7. Now the key is that's the x and that's the y. So I'm going to plug 1 in for x because those go together and put negative 7 in for y. Now notice, two negatives, so the two negatives really become a positive. Okay. Now the last thing is we want to put it in slope-intercept form. So that's y equals mx plus b. So here we want to get y by itself. So that's the key. So I'm going to distribute 5. And the last, I'm going to move the 7 to the other side. Now the key here is this equation and this equation are the same. The exact same thing, okay? And we could see that, for instance, here. If I was to extend this and say, where does this line cross the y-axis? We can see that right there, and that point is 0 comma negative 12, okay? So it's the same thing, but depending on where we start. Do we start here or we start here, depending on what information is given. So this objective here is, can we realize there's different ways to write an equation, and we have to pick the way that's most suited for us, okay?